Was Dr. Werner von Braun correct when he says a rocket with engine pressure of only 0.14 psi is enough to dig a crater below his moon ship?
First of all, this quote was made in 1953. That's right, 53. Back in a time before there had been any lunar probes, and there was considerable concern about just how loose and how deep the lunar soil would be.
Australians all, let us rejoice, for we are young and free. With golden soil and wealth with soil, our home is good by sea. Oh, our home is good by sea. I love nature's gifts, a beauty rich and rare. Let history's pace, let every stage advance Australia fair. Come on, choir. Oh, and that's Australia's fair. And the second verse that no one ever knows. Within the radiant southern cross, following paths of...
You also conveniently failed to mention that he said a small crater. Well, all the Apollo missions left craters up to 6 inches deep in the regolith, too. Why don't you go watch Phil Webb's very scholarly and thorough video answer to this very question? The link is in the sidebar. Your question here is yet another classic example of quote mining.
Oh, and don't worry. Unlike you, I have no need to quote mine. Jay Winderley claims minor solar flares can't hurt you. Is that true? I have no need to quote mine. J. Warren Keller, quote mine. Russell D. Shelton, quote mine. Martin O'Burrell, quote mine. And James A. Downey III of Marshall Space Flight Center, quote mine.
Wow, 5 false accusations of quote mining.
All state that minor solar flares can take anywhere from 2 centimeters to 36 centimeters of water to reduce the dose to 25 rem per hour. Is this true?
I have seen where Jay Windley makes such a comment, and taken in proper context, it is essentially correct. For astronauts, shielded the way the Apollo astronauts were, minor solar flares are virtually harmless.
Virtually? As in, not entirely?
As for the other 4 you quoted, 4 people who your hero Ralph Renee would call heavily credentialed gas bags,
And yet, he cited them, praised them, and used their research as factual. Your vast knowledge of your opponent's work is really starting to show.
First of all, I'm not sure I would accept your translation of their findings, as the term give off more than 25 rems per hour does not sound very scientific to me.
Funny, because as we saw in the previous question, John Malden used the term too. Would you prefer if I used the term deliver more than 25 rem per hour? When you need to attack someone over trivial wording like that, It only demonstrates how weak your position is, not to mention how pedantic you are.
Secondly, I don't think you have any idea what their findings imply, and you don't have a clue what that graph represents, as far as hazards to astronauts.
Unlike you, I have no need to quote mine.
Nice logic there. You blindly accept what Windley says as factual, but when a group of scientists say something contrary, you dismiss it as quote mining on my part without a shred of evidence. Just so that there is no doubt as to my understanding of their research, let's have a look at this graph. The x-axis for this graph represents water shielding given in grams per square centimetre. The y-axis represents the radiation dose. These curves on the graph represent individual solar flares. The closer they are to the right-hand side, the more water shielding is needed. The higher they are on the graph, the more radiation they deliver. The lowest dose on the chart being 10 to the minus 1, or 0.1 rem, and the highest being 10 to the 7 rem, or 10 million rem. Now the unit for radiation dose is given in rep, not rem. However, the authors state that substituting the rep unit with rem is not far off at all. 2 pages earlier, we find, contrary to what might be expected, much of the radiation encountered in solar proton outbursts appears to reach the vicinity of the Earth in isotropic distribution, thus necessitating protection from all directions. Figure 14.5, taken from Source 5, shows one set of rough upper and lower estimates for the integrated dose as a function of water shield thickness for low-energy flare events of August 1958, May 1959, July 1959, the intermediate energy event of November 1960, and the high-energy event of February 1956. While the dose is given in Röntgen equivalent physical, rep, the RBE for high-energy protons is close to 1, and therefore the units may be considered as Röntgen equivalent man, rem, with little error. However, these curves consider primary radiation alone. Some estimates for the secondary problem for such flares have been made. This line across the screen represents 25 rep, or 25 rem. If the curves go above this line, the flare delivers in excess of 25 rem. If it drops below the line, the flare delivers less than 25 rem. This graph shows the low energy flare of July 1959 and the low energy high flux flare of May 1959 would both require 31 grams per square centimetre of water just to bring their respective doses below 25 rem. Without this shielding, the dose would be quite unpleasant to say the least. And these are just minor flares.